we have discrete random variables. Your definition for random variable is numerical measure of outcome of probability experiment. So what we need on this part is discrete random variable, and here on this side we have continuous. What is the difference between these two? For discrete, we can count what we have here. So we are able to count this part. See, on this part we have how many points we have on this number line is I have 1, 2, 3, 4, 5 points. So this is countable. But on this part, continuous random variable is we cannot count these, we only can measure it. See, I don't know how many points we have here on this line. So starting from 0 up to 4, we may have like rational, real numbers, integers. So all the numbers we can have here. So we can say that we have too many numbers on this part and it's not countable. So it's not countable. Example number 1, determine whether the following random variables are discrete or continuous. Part A, the number of light bulbs that burn out in a room of 10 light bulbs in the next year. So here, this part is discrete because we can count these. So I want to use X instead of light, and that starting from can have 0 light and light bulbs, and 1, 2, 3 up to 10 light bulbs. And part B, the length of time between calls to 911. So it's time between, and this time is not countable. So we have this as continuous. And for time, I'm using t, and t always is greater than 0. Okay. Now here we have rules for discrete probability distribution. So for probability, we're gonna use this p, meaning that probability, and x is random variable. So random variable x equals x. Then we should have these two rules. Number 1, sum of all these probabilities should be equal to 1, and also each one of these should be between 0 and 1. If you had these two, that means that you have this probability rule. So you pass that rule, and now on this part example, we want to apply that rule here on this part. So which of the following discrete probability which of the following is a discrete probability distribution? Part A. Okay, so the first rule, we should add all these numbers. Okay, but let's see, before adding that number here, based on what we had on the rule, second rule, here we have negative number. See, on top we have the second rule. This should be between 0 and positive 1. But here is less than 0, is negative number. So negative 0.15 is not less than, okay, it's not between 0 and 1. So the answer for this part is no. Because probability of x must be between 0 and 1. So between 0 and 1. Now part B. Okay, here is typo. I have exactly the same thing. I'm changing that one. So let's change just one to, for example, 0.34. Okay, so all these numbers are between 0 and 1. So we passed second rule. Now let's try first rule, adding all these numbers. That is equal to 1.49. And this should be equal to 1, which is not equal to 1. That's why we didn't pass first rule. So the answer again for this part is no. So the answer here for this part, no. Because the sum of all these probabilities must be equal to 1. Okay, now third part, part C. Here for part C, all of these are between 0 and 1. So here on top, here also I have this equal to. So probability of x should be greater than equal to 0, less than equal to 1. And here all of these are between 0 and 1. So we passed first rule. And second rule, adding all these numbers. So add all these numbers is equal to 1. So what that means, we pass the first and second rule. So the answer is yes. Yes, that says discrete probability distribution. All of these probabilities are, so this is the probability x1. You can say, okay, p x1, x2, x3, x4, x5, because we have 5 variables in that part. So all px, or all probability of that variable x, are between 0 and 1. And also adding them is equal to 1. Okay, now here is the meaning of a discrete random variable, and on this part is standard deviation of discrete random variable. So this x is value of random variable. And p of x here is probability of x. So same thing for this part. This is the value, and here is mean, and here is probability of x. Here I'm gonna use the first one to find the standard deviation. Or we can use calculator. So for calculator, we need to enter data first. So I'm writing steps here for you. So first, using TI 84, press that. Then enter. So on this part, enter data. After you enter data, then again stat. Then press OK. So after you has that, you're gonna see here we have on top we have enter, then we have calculate. So choose this one. Then after that, choosing the first one, we have word stat. Okay, then you can see the answer is like this. This one is mean, and here we have standard deviation. And if you scroll down, we can see like Q1, Q2, Q3 like that, and those. But you don't need that part for this one. Okay, let's work on example. Example 3. The following data represent the number of games played in a series of an annual tournament from 1928 to 2006. Okay, so we have on the first row we have X, and that is for games played, and here is frequency. How many times that 4 was repeated here. So that's why this is frequency. We had this part before. So for A, construct discrete probability distribution for the random variable X. So here on this column we have our X, which is on exactly what we have here on top, 4, 5, 6, 7. And on this part, we should find probability of X. Okay, so first, find sum of frequency. So adding these numbers. So sum of frequency is 16 plus 11 plus 22 plus 28. That is equal to 77. Now to find probability of X, divide frequency divided by sum of frequency. So 16 divided by 77. 1 and 2, 3 decimal places, we have 0.208. Next one is 11 divided by 77. So that is 0.143. Then here is 22. So 22 divided by 77, running it, it's 0.286. This part we have 28. So 28 divided by 77. It's 0.364. So first I want to find the answer using the formula that we had on the previous page. Then we're going to use calculator to find the answer. So finding mean. So that was equal to sum of our value times probability of x. Okay, so this is equal to, so here is x and here is p of x, so 4 times 0.208. Then we have sum, so in between use add. Then we have 5 times 0.143 plus 6 times 0.286 plus 7 times 0.364. So what we have here is 0.832 plus 0.715 from 0.716 to 0.548. So that is equal to 5.811. Okay, so that's our mean. Now part B draw probabilities is choose the correct one. So based on what we have here on top. So here on this part we have our value x, and on this vertical line we have probability of x. So starting from that point, if you had 4x, you should have 0.208. Here is 0, 0.1, 0.2, 0.3, 0.4, and 0.5. See, this one is 0.3. Here it's close to 0.1. And here is 0.3. But that means here is 0.208. But that means this is the correct one. Well, let's make sure that the rest of it is correct. So if I have, this is 4, 5, 6, 7. So if I have 5, I should have 0.143, correct. Then for 6, we have 0.286, correct, because this is less than 0.3. And when you have 7, that is 0.364. Okay, so this is the correct answer. Then part C, find mean of random variable x. So we already got the answer on part A, but on this part I want to use calculator instead. So I use calculator or TI-84. So first you need to enter data. So let me show you calculator. So I don't have software installed on my PC, but I can take picture of what I have here on my TI calculator. Okay, so first step, press start. After you press start, you're gonna see this page. Okay, so choosing the first one edit. So after that, you need to use enter. So press enter and then enter data. So entering data. Here is what I have. So to enter data, press 4. For example, the first one, press 4 and then enter. Then press 5, enter. Press 6, enter. And then move to, so after you entered all these, move to L2 and enter all data for probability of x. So this is what we have for our value x, and this column is for probability of x. After that, again, press that. So this is what I have again. And then you need to choose this calculate. So move to that point. Okay, here is what you should have. Now choosing the first one, word stat, press enter. Okay, here is what we have. You should have list L1 and here you should have L2. If you didn't have this L2, your answer will not be correct. So if in case you didn't have L2, you can enter it by pressing second and then press 2. So second, 2, you can enter L2. Okay, then after it, enter, again enter. You can see the answer. Okay, so here is what I got. So this is mean. I got 5.800, but without calculator we got 5.11. It's not that bad. It's very close because that is because we rounded our numbers for probability of x. Okay, so and here we're gonna use this one for another part. So for standard deviation, we have 1.139. Rounding it, we can have 1.14. Okay, let's go back here. Okay, so using calculator, we entered L1, L2, and then we used var stat. So after we press that one, we saw this list L1 and frequency should be L2. So then press enter. The answer we got mean rounding it, we got 5.800, or we can write 5.8. So this was using calculator. Okay, now part D, interpret the mean of random variable x. So based on what we got on part C, what that means. So mean means we have on average. What we have on average is the number of games played, or x, in each series is expected to be about 5.8. Okay, now part E. Find standard deviation of random variable x. Okay, on this part I want to use, I want to find the answer without calculator first. Or I only will write, I will write the formula for that part, and then you can use calculator to write the final answer, because it's time consuming if you don't use calculator for those part. So standard deviation is equal to, this is from previous page, square root of sum of what the value is minus mean. I'm using the one that we got using TI-84. So for mean we got 5.8 times probability of x. Okay, so that is equal to, okay, we need to add, so our x is starting from 5, okay, here 4, 5, 6, 7. Here we have all these are for x, and that's for this probability of x. So 4 minus mean from previous part is 5.8, then square times probability of x is 0.208. So times 0.208, then plus 5 minus, again, mean, square, times probability of x. See, this column is probability of x based on what x is. Now for x equal to 5, probability of x is 0.143. Then plus 6 minus 5.8 squared times, we have 0.286, then plus 7 minus 5.8 squared times p of x for this part is 0.364. Okay, so this is equal to so we have 3.24 times 0.208 plus 0.64 times 143 plus and here is times 0.364. So here we have 0.67, 392, 0.0, 91, 52, 0.0, 11, 44, plus 0.52, 416. Now square root of 1.3104. Running it, the answer is 1.14. And also using TI-84, we got exactly the same thing. Okay, so here was section 1 from chapter 5. I'll later work on 5.2. Okay, so bye-bye for now.